Good morning, everyone. I welcome you all for the first session of the first day of today's conference on quantum physics, brain function, modern science, and Buddhist philosophy. Dear all, myself, I'm Niranjan. I'm the coordinator and moderator of this first session of the first day of the session. So, recently when we planned to organize this event, I was going through one of the PPT YouTube video. One of the Nobel awardee quantum physics scientists mentioned that if somebody says he knows quantum physics, it means really is not. It's a vast subject and there is no never-ending subject. Still people are doing R&D on quantum physics and quantum mechanism. So, today's first session, chairperson of the session is Most Venerable Khentrul Rinpoche, Geshe Tashi Siringla. Hope all of you have gone through the introduction of Geshe-la, and I would like to give a brief introduction again. Khentrul Rinpoche received his early education in school run by Central Tibetan Administration, India. He enrolled as a monk at Sera May Monastery in South India in 1970. In 1990, he finished Geshe Larpa degree. He has been teaching Buddhist philosophy in the West since 1991 till 2018, mainly in the UK and other countries. He had written 6 books on Buddhist philosophy and practices and created a 2-year online course. The foundation of Buddhist thought. He completed his MA in social anthropology at the School of Oriental and African Studies, London University in 2018. His Holiness the Dalai Lama appointed him the Abbot of Sera May Monastic University in India in 2019. Of his services of Buddhism in the UK, Khentrul Rinpoche Geshe Tashi Sering was awarded the British Empire Medal, what we call BEM. I welcome Khentrul Rinpoche to chair the session. Thank you very much. Please. In the first session, along with our chairperson Khentrul Rinpoche, we have Dr. A.R. Usha Devi, and she'll be talking on survival of quantum superpositions. I welcome you, madam. And also we have Dr. Ravi Prakash with us, quantum decoherence and cognition from some unexplored questions. I welcome Dr. Ravi Prakash ji. Please. Along with us, Dr. Pranshu Samdarshi, the Madhyamika tradition of Arya Nagarjuna and quantum physics, analyzing quantum decoherence from the Buddhist perspective. I welcome you, sir. Rinpoche, it's over to you. Thank you very much.
So we are going to start this first session, and I welcome to the 3 distinguished speakers and also other scholars and participants. And this session main theme is decoherence in quantum physics and the parallel in Buddhist philosophy, and that's the main theme. And our each speakers has about 20 minutes to speak on their topic, and I will signal around 18 minutes to conclude your talk. And I'm sure all 3 speakers are well attended these kind of conferences. Therefore, I don't think I need any disciplines when to end and so on and so forth. But each speaker has 20 minutes, and at the end we'll have another about 15 minutes questions and answer sessions. And the people who like to ask question, just have one simple question, straight, just not too much background, because we don't have that much time. And also whom that you are going to ask question, that will be helpful not to get confused. Just say that I'm going to ask to such and such doctor. That will be helpful. So our first speaker is Dr. R.A. Usha Devi, and she's teaching in a Department of Physics in Bengaluru University. She has done quite some time, almost more than, I think, around 20 years. And she has done lots of research on this field, quantum mechanics and so forth. She had received the MS gold medalist. Okay. And also she, in 2008, she was awarded Commonwealth Fellowship and studied in Bristol University. And Dr. David has published more than 50 research papers. So I'm sure her talk on the topic will be extremely exciting and interesting. Please start your talk.
Thanks for your introduction, and I'll try to explain this notion of decoherence in physics within the limited time. So basically, I am Usha Devi from Department of Physics. This is the picture. So basically, when quantum mechanics began, I'm showing, it went somewhere. I don't know where it went. This is not working. Oh, can you show it to me? There is some problem with that. So basically, quantum theory was formulated by three people. That is, to say it as fathers of quantum mechanics: Heisenberg, Dirac, and Schrödinger. And Dirac, their formalism was different, but Heisenberg's formalism used some abstract concepts, matrices and other things, but Schrödinger's formalism was more appealing to physicists at that time. So Dirac was able to identify that Schrödinger's formalism has a notion called as superposition. So this superposition became, that is, through this formalism, there are a lot of philosophical identification that came. So, yeah. So,
No, you need to point here.
oh, right. All right. No. I should get down there and,
What do you do?
yeah. So, yeah, that's better. I'll try that. So this is quantum mechanics is a complete theory, is what they said in 1927, because there are a lot of debates going on. So you have quantum mechanics is a complete theory is what Heisenberg and Max Born announced in 1927, but there were philosophical debates, as I said. this won't work. So please, next. So this is one famous physicist. So he says when he was studying quantum mechanics, the Copenhagen interpretation told us that shut up and calculate, don't ask questions. So this is what he thought quantum mechanics professors were teaching. And if you don't shut up, what happens is the next story. So I will go ahead. So Einstein was one of the innovators, that is, he had proposed quantum theory, some basic concepts, but he himself was not happy. Professor Ghosh told, our Partha Ghosh also mentioned, God doesn't play dice and spooky actions. So Einstein did say, I cannot seriously believe in it because the theory cannot be reconciled with the idea that physics should represent a reality in time and space free from spooky actions. That is his belief in any theory. A theory which describes whatever nature should be free from spooky actions, is what Einstein says. So please, next. So this was the paper which was written in 1935, which talked about what is the problem with quantum mechanics in the sense of what is reality. What do we call as reality? And does quantum theory explain this concept of reality in a complete fashion? This is what was talked about there. Next, please. So this, after Einstein's death in 1964, till that period from 1935 to 64, there were some kind of coffee table discussions and other philosophical discussions where people discussed about what Einstein said and what could have been quantum theory. Do we have an alternate theory? There are many, many more progresses, but to cut it short, I will say the CERN physicist John Bell, he wrote on Einstein-Podolsky-Rosen paradox. That is a theory, if it has to be explaining reality and completeness, what is the problem with quantum theory? So John Bell wrote a paper in 1964. So then he was a CERN physicist, but he was on a sabbatical leave. He could attend to his passion and he could write this paper. It's nothing to do with any CERN physics program. He wrote this paper on what are called as hidden variables. We have to have hidden variables. Then what should be a theory, which is satisfactory to Einstein also. So no spooky actions, only hidden variable theory. So that is what was done in 64. So with that, he just defined, there are some simple definitions like what we call as realism. In mathematical notions, if I have two separated parties and one party does a measurement, whatever is obtained, that is reality. Then other party has to do nothing with it. That is, we are separated. What I do here should not disturb this. That is, no spooky actions. So that kind of assumptions are put. So reality is, there exists a reality for both the parties. If with that kind of a simple thought, that is separated parties, there is no spooky action. That's what was thought. But then if you formulate, next please. So there is an inequality which I will not talk much, but each term, there are 4 terms in the inequality. That is, each term can carry a value 1 or minus 1. If you take this, it can be less than or equal to 2. Any local theory should be less than or equal to 2 is a precise way of talking about it. A local real theory with an example should have this kind of a bound. Our physical principles place a bound on this inequality. So if it is not a local real theory, as Einstein would like it, I don't know what happens. So put 2 theories into test with this kind of an inequality. So what is really real is a big question, but in the context of Bell inequality, we can say that experiments will come to our help. I will take a physical system and do an experiment. What I got was violation of the inequality. So my world is not local real or whatever. It doesn't obey local realism is the reality for us. We still don't know what is real. So with that, there are many tests. Is it loophole free? I should make it loophole free. There shouldn't be any foolproof kind of a argument is there. It is violated. So we don't have a local real theory as Bell had asked and set a bound on that kind of a inequality. That is well known to us. So next please. So same way as we talked about local realism, there is another concept called macro realism. Macro realism is a concept. We do know quantum theory works with whatever are called as subatomic, microscopic kind of objects. But if it comes to me, you and all, we don't use quantum theory to describe us. So then the question is, our theories there should be kind of a smooth transition as far as we are concerned. Is it there? Is a question. Then there was a definition called, some kind of a concept called macro realism. Is my theory macro realistic? In the sense, in a macro domain, I have certain rules. If it is obeyed, then I have satisfactory, but I can sense it, I can perceive it, that kind of reality. So this is just a kind of, what is the macroscopic realm? When do superposition die? Is it surviving? Is the question. So next please. So this was formulated by Anthony Leggett and Anupam Garg. They again formulated what they mean by macro realism. So their definitions say, physical properties of any object that I am dealing with to my satisfaction, it should exist independent of any act of observation. That is one thing. I should have it. Then other thing is, if I do a measurement of the observable at one point of time, it shouldn't disturb its subsequent travel. I have an observation, after some time it shouldn't change because I observed it here. That's the kind of definition that they give. So then I will skip it, but it is like, I will take a simplest observable where I will say this has values +1, -1 to make it mathematically precise. So I take an observation of an observable at time t1, at time t2, at time t3. They say that. And next please. So they write some kind of a correlation between one time observation with the other time observation, which can be done. If they write, please next. So this is the last -3 less than or equal to 1. That kind of a thing is called Leggett-Garg inequality, similar to Bell inequality. If I do that, any macro realistic following theory should obey this kind of inequality. This is for mathematical precision that we are doing. Next please. So we'll go ahead with it. If I go to quantum theory, I do get violation. It's going beyond 1. That's what was seen. So quantum theory is obviously not macro realistic, but the question is, when does such a transition, or what is the twilight zone between quantum and classical theories? We should connect them. Otherwise we are just putting one theory here, one theory there, and we are not patching it up. So that is a basic question for physicists, to have a smooth transition that still continues, but some attempts here. So next please. So this is an experiment where the violation is seen in whatever is called as a quantum spin-half particle. So that is different. What is that and all that? But the violation is seen. It's beyond 1, quantum and classical. But the observations, as time progresses, you do see that violation decreases. The question is, why violation decreases? It becomes classical soon. So this is because of the environment. So we say that system is never closed. If I could preserve a quantum system in some kind of a safe locker, it will remain as violating. No macroscopic domain comes. But if I have an interaction with the external world, then what happens is, I do see it classical. So we are all some kind of a quantum transitions to classical world. If we say it, extend it, but I can't say it yet. With quantum systems, I can say when it interacts with the environment, I am going to see classicality. That's the kind of features. So that's the situation. And also, if I cannot slice time closer to the domain where I can still see quantum mechanics, I'm not going to see quantum features of quantum theory. These two are different, but if I have to see quantum superpositions and decoherence free kind of things, I have to slice my time, measurement time, observation into shorter and shorter. Only closer to that starting point I will be able to see quantum features. That's the kind of identification. Next please. So this is like, if I had, this is a famous Schrodinger cat theory. So where Schrodinger said, if I can explain a cat with quantum theory, and I put it in a box with poison, if it eats poison, it is no dies. If it doesn't, it will stay alive without looking at it. That is because reality exists everywhere. Without opening the box, can I say cat is dead or alive? So quantum theory wise, it says it can be either alive, either are dead, which we don't know. So this is the kind of identification. But then we have contradiction. That is, we don't know. We can't see such a feature in our day-to-day world. Why is this theory is there? So next, please. So this is basically what one takes it in quantum theory. I have suppression of quantum superpositions because of noise. It's dynamical in the sense we are never closed system. We have an open system dynamics. Sure. So I'll go ahead. So this is classicality is enforced. So I say quantum world that side, classical world this side. Stop. You have to have classical apparatus. I can see you because of my classical viewing, but quantum world is different. So if I see it, cat can be alive or dead. So next please. So I will not talk about it. Next. So next please. So I will not talk about these mathematical details. Next. So one finds that if I have whatever we did explicitly mathematical model shows me that superposition is the first picture. All four peaks are seen. It's in mathematical way. Next. Superpositions die, that is, I have only this or that, either this or that, dead or alive kind of a thing. And then there is a time which is measured. Decoherence time is some kind of a mathematical thing which I will show in the next slide. So this is, if for a system, I take system, I have to have mathematical description. There is temperature of, let us say 300 Kelvin, something like room temperature. Then I will take a particle of mass 1 gram and it is say separated by some 1 centimeter. So two states are separated by 1 centimeter. Then I will see that ratio of these two. Even if I take, it can survive for 10 to the power 17 seconds, that is age of the universe. I will find that suppression of superposition happens in 10 to the minus 23 seconds. It's so fast. That is, I will not be able to see what is superposition if I stick to, without keep it preserved. I have to preserve it by some methods. People in quantum information processing are trying to prolong that and keep it decoherence free so that we can see quantum features. Otherwise, I will see what is comfortable for us. That's what is nature. So these are some references that I had. Next, please. So this is again the inventor of this decoherence word was Professor Zurek. He had talked about in many popular articles are also there. His cartoon is this. There is a no trespassing kind of a zone there. That side is different. This side is different. There is some kind of a connection. But connection can be understood in some ways. That's what is the situation. Next, please. Thank you for your attention. Thank you.
Thank you. Thank you very much, Dr. David. And I don't know how to summarize. My head is completely blown. So, anyway, thank you very much for your talk. And it seems to me you started with how this discipline is started with these three great thinkers, and then moved on to Albert Einstein to 1933-35, how he sees the theory, and then you talk about another great thinker, John Bell, how he put the different theories and how he come to saying local realism and or macro realism. Yeah, and then that also there are some contradictions, there are some difficulties to get the acceptance by all the scholars and all the thinkers. And then these two other great thinkers, Leggett and Gray, Gard, they came another view of macro-realism, and then you move to talk about classical, the quantum mechanics theory and theory and class, and also quantum mechanics. And so it seems to me you are saying, if you are looking at whether the cat is already dead or not, then you will understand. In other words, there's no any conclusion to. Is it that your main point?
I will not be able to see,
it
alive or dead unless I have very close people
okay.
are doing
it. So I mean here, I'm not sure whether it's similar or not. In the one of the Buddhist philosophical schools, they talk about very much how reality is very much how we observe, not very much out there, what's there as a reality. It is very much observers' interaction with the things and events, how they come together. And that's what I'll conclude. Thank you very much. So our second speaker is Dr. Ravi Prakash. He is a psychiatrist and neuropsychologist and a freelance researcher, conducting researches in quantum epistemology. Quantum epistemology. Oh, this is the first time I heard that. And consciousness. His interest in consciousness has led to publish of several papers and books on the topics of near-death experience, yogic state, quantum epistemology, and the role of cognition in the quantum theories of consciousness. Having over 120 publications, he has been an advocate of integration across various fields of psychology with the other branches. Really amazing. Please start your talk. You go there? Okay.
Thank you so much, sir, for the heartening introduction. And I'm Dr. Ravi Prakash. I'm a neuro psychiatrist, and I'm practicing psychiatrist. And my interest is in this quantum epistemology and understanding the possibilities of quantum interactions in the brain. Actually, Madam has already presented so detail about the quantum decoherence. I will be just touching the cognitive and the parts that are related to the brain, actually. So it's a very interesting time right now. I would say 2014 onwards, I guess I'll have to present without PPT. It's fine. So anyhow, I'll not go into so much technicalities, although I thought of making it. But the core idea is that after 2014, there was a development of a new branch called as quantum cognition. And the quantum cognition that is right now very much a thriving branch of, I would say that is one very interesting field because it's a thriving branch including two different branches. Psychology is also there and quantum physicists are also working on that. And in the quantum cognition, what is being implied is that the earlier ideas of understanding the brain using quantum mechanics were actually modeling the quantum states inside the neuron. But they have failed miserably, I would say. And when I was in MBBS, I was finishing this Roger Penrose and Stuart Hameroff model, it came, the orchestrated objective reduction model in brain microtubules. But over the course of time, so many researches it happened. And because of so many reasons, the noisy environment of the neuron, the enormity of the neuron is so big that it is very difficult to identify, and plus how do we identify what is going on inside a neuron? So all these factors, because we are talking about a living thing, and even if we open the brain of a rat, it is going to die. So keeping the rat alive or keeping the animal alive, and in human beings obviously you cannot do, so it becomes very challenging in a living neuron how to understand the concept of coherence. Nonetheless, when intelligent people come together, they do amazing things, and I'm very, very thankful to quantum physicists around the world. Actually, they have brought up the concept of the quantum probabilistic modeling to the brain functioning. And so right now the trend is not to model actual, or not to imagine the actual quantum state inside the neuron, whether it is microtubule or any molecule of the neuron. But right now the more of the interest is towards using the quantum probabilistic modeling, that means to say the model of the quantum calculations into the brain probabilistic models. And there are several things. I had published one paper in 2006 in Annals of Indian Academy of Neurology. That paper was specifically concerned. At that time I did not know that this can be used for quantum stochasticity. But at that time what we were trying to do is that we were trying to find out that whether as if you know how the neuron works to develop an action potential, you will know that it is about the opening of certain ion channels. And the ion channels, very strangely, they can be affected by local field potentials as well as distant field potentials. And that whole process where the phase locking happens, the epaptic conduction happens, all these things, they contribute to the stochasticity, the opening and closing of the ion channels. And here we are talking about opening and closing to such a level that it can lead to firing of a neuron. The action potential can be generated. So that's minus 55 or minus 40 different different neuron parts of the body, they will have different threshold potential. So if the threshold is suppose minus 55, and because of the opening and closing of the channels you have already reached 50, then the pyramidal neurons, when they will fire together, they will lead to a distant correlation through the electromagnetic field of the brain, and it will lead to the opening of the channels. There have been several studies behind that, but it is just one of them. That is why the stochasticity, the randomness of the opening and closing of the ion channels, they can be affected, they can be manipulated by so many different variables. Local field potentials, the channel themselves, which part of the brain it is, how many EPSP, IPSPs are coming to the neuron, how many dendrites it is having, so many things. That is why the classical computational models are failing miserably to define what could be the outcome on a neuron. Till this date, we don't have any model. This artificial neural networks that we talk about, that we are talking about the algorithm of the ANN using outside. But till now we do not have any model where the actual neuron, even if it is like 4 or 5 neurons, it can be simulated outside. We don't have any model. The reason is that it is so complicated, so stochastic, so unpredictable, indeterminate. These are the questions that they come, and after having tried for so many years, now people are going towards the quantum physics, and definitely quantum physics is providing certain answers. The concept of criticality, the concept of phase modulation, the concept of calculation of the outcome using the different variables. The Schrodinger's wave equation can be used to find out many variables. This is what I'm talking about at the level of the brain. But interestingly, the same thing can be applied at the level of cognition, or you can say at the level of psychology. And for that also, if you have to define quantum collapse or quantum decoherence or say wave function collapse in terms of decision making, then what we mean in cognitive terms, I'm saying what we mean is that from a state of infinite variables coming to one or two determinate variables as the output. If the input is say near infinite, the output coming to near one or two determinate variables, that happens in our decision making process all the times. Every time it happens, but it has become so habituated into our responses, so ingrained into our responses that we hardly notice. Okay, so for example, if I have to say that, suppose you are traveling by boat and one of your family member falls, okay, into the river. The answer, what you will do, will be very simple, because here there is one variable actually. It is kind of a linearity that is there. You will jump, you will try to save, you will do what you can do. But now let me complicate it a little further. Your mother has fallen, seeing that your father has got a heart attack. With these two things, the person has become boat person has become out of control, and he's trying to disorganize all the things which are there in the boat, and he is trying to control everything that is going around. So what will you do at that time? These two variables. Similarly, 4, 5, and in the brain we are talking about near infinite variables. Okay, therefore the outcome to calculate by classical computing is actually very difficult. I would say it is near impossible. That is where these things they come into the picture, that you can just use a probabilistic model which is already there for subatomic particles, and you can use it to calculate the outcomes for decision making processes, selecting attention, or trying to find out the solution to many irrational behaviors. We do so many irrational behaviors all the time that it cannot be exactly predicted by just simple computing or linear computing. Okay, when the concept of linear computing, simple computing, it came to the neuroscience through the Laplace's models. Dr. Laplace, there is a whole phenomena called as Laplace demon. Madam may have heard, it's called Laplace's demon. So Laplace's demon is a hypothetical organism, human being, non-human being, it's a hypothetical organism which is perfectly intelligent of all the outcomes that are possible in the near future. It can see, it can recognize, it can choose. But does it happen in our real life? I would say I will not be able to choose whether I want tea after 5 minutes or not. Okay, it depends on so many different variables. That is why quantum computation helps to a larger extent in cognition also. And the superposition, classical example of improbability. I did not know that this is going to happen. Okay. So, I'll just see if it is working or not. Oh, they're here. I think lack of time, I will go ahead. So, in the classical computing, this is how it is shown, that at T1, the state 0 is there. If all the laws of nature are applied, okay, then the state S1 and S2 should be completely predictable. This I'm talking in terms of Newtonian mechanics, or you can say Laplacian's mechanics. Okay, without wasting time further. Oh, thank you. This one? Right. This for later. Okay. So the Laplace's demon is actually an impossibility. We can never know for with utmost certainty. We can know with certain certainty in computers because the variables are limited. But in real life, when we are talking about a complicated structure like brain, it is near impossible to find out just by Laplace's laws that what will be the output. Okay, these other things, high stochasticity of brain neurons, this I have covered up to extent. I'll just skip. So the quantum mechanics right now, it is being applied in this quantum probabilistic modeling more than actual quantum models inside the neurons. So right now we are less concerned about what is happening inside the neuron because we understand the impossibility. Maybe in future when we have advanced technologies, we are able to simulate the neuron outside, we may be able to find out. But right now quantum probabilistic modeling is being used to understand the high degree of randomness as a statistical outcome in the neural networks. Okay, I'll just skip it. Who will explain decoherence better than Madam? So I'll just skip it. So these were the models. Penrose's Hameroff model was the initial model which was celebrated a lot when it came. But as time passed by, the results were almost nil. We were not able to find out that whether really it can sustain, the microtubules have the capacity to sustain. And the more recent studies, they say that no, it cannot be sustained. It is so fuzzy inside, the temperature is so fluctuating. And as Madam mentioned about the time scale, we need to measure at 10 to the power of minus 23 second time scale. That's almost impossible to find out. Okay, so recently, I'll just finish, thank you. So recently the calcium phosphate molecules in neurons, they have been studied. These are the, as I mentioned, noisy warm environment is there, quantum effects, they average out. That is the reason. Okay, this I will cover a little bit. So, in the sensory system of human neurons, as well as animal neurological system, many of the quantum effects have already been found and described, like quantum tunneling effect, like quantum entanglements in the cryptochromes of the birds, as well as in the avian magnetic compasses that they have. This is for animals, for humans also. Okay, in the rhodopsin, there are many activities which can only be explained only by quantum superposition and quantum tunneling effects. Okay, the same thing with olfactory receptors. The without electron tunneling, it is not possible to have an olfaction. That is almost true nowadays. Okay, so at the level of neuron, these are the two main things: ion channel stochasticity and the firing of neurons. These are the two major places where the concept of quantum probability calculation is being applied now. Okay, neuronal avalanches, this is a different topic in itself. When we will understand a little bit about the criticality. There is a phenomena called as criticality. That means to say, it's a very interesting phenomena. In the brain, suddenly sometimes a group of neurons, they start firing collectively without any known reason. These are called as neuronal avalanches. And with any deterministic model, it is very difficult to find out why they start firing. Okay, only by quantum models we have been able to find out up to some extent. Just 2018-19 few papers have come. Till then it was just a mystery why neuronal avalanches are there. I'll go to the main thing. This is the main problem, that the probabilistic theory of calculation, it cannot give an answer for irrational behaviors, it cannot give an answer for the question of free will and moral responsibility. It cannot give the answer for behavioral paradoxes. All these things cannot be answered by probabilistic models, computational models in classical terms. So we need more probabilistic models. So the good thing about quantum physics is that it is embedded in higher degrees of improbabilities or probabilities, you can say. This is very interesting thing. So it is from an article published in Nature. So the neuronal firing itself can be seen as a state of quantum superposition. So at minus 70 millivolt, the neuron is quiescent. And minus 55, when the threshold is reached, it leads to a firing. So actually there are two states here only, quiescent state and firing state. And this superposition, earlier so easy we were thinking, it is not so easy. The firing of the neuron in between this phase, reaching from this minus 70 to minus 55, it is dependent on so many different variables. Local field potentials, distant field potentials, and one of my paper which explains this was basically about this only, that how when pyramidal neurons, this is a pyramidal neuron, and when the dendrites are there parallel to each other, when they fire together, how it leads to a phase locking in the electromagnetic field of the brain, and that ultimately affects the firing, the opening and closing of the ion channels. These are the ion channels. Okay, very, very bad diagram by me. But luckily it got accepted, and it is one of the good cited articles. And we can see that the synchrony of the actin potential happening somewhere in the brain, in the cortical area, can lead to the firing of neuron in another area, nearby only, but another different area, which is completely non-local in nature. So how do we explain? We don't know the answer. So we go to the quantum physics. Okay, so these are at quantum probabilistic model at neuronal level, some results have been found. These are all references you can see from online. So this is what Dr. Busmeyer and Wang, they were the people who coined the word quantum cognition. And this is a very exciting field, I would say. More and more researches are being done. And I would just try to finish it off. In future directions, this is very important. What do we need? The more important thing is that in future direction, we need to, as we are talking here, some large-scale neurons and neural circuits are currently being developed outside as an artificial neural network. This is what we need actually. Until we have that, it is near impossible to understand whether really the probabilistic nature of the neuronal firing or the electromagnetic fluctuation, it is because of quantum phenomena, or it is just because of some extravagant mechanism of classical computing itself. It's impossible to find out. So as we are talking, already the neural circuits are being developed, and the people are predicting that some observed quantum phenomena like decision making will be incorporated in these models, and the classical modeling will fail to account for that. The only way we can account is like understanding the quantum like decision making models. Okay, this Dr. McFadden, I have worked with Dr. McFadden for a brief period of time. We were trying to develop jointly one global workspace model, but at that I'm talking about 2006-7. So at that time the sophistication was very less. Maybe now we can start working. Okay, so that's it. I'm sorry. Thanks.
Thank you very much, Dr. Prakash. Again, what I'm going to summarize, I don't know, but you started your interest in quantum epistemology, which is your main interest, and it seems to me, what you are saying, it is not predictable in our neuron activities, what to make the decision and how to make the decision. And many of the classical, the theories are not that much applicable.
Yes.
And something, the neuron cognition theory. Neurocognition, did you say that? Cognition. Something in the future may give some kind of answers, and the determination theories are not that much applicable, and more probability, or some of those are may able to apply to get some answers. Thank you very much, your inspiring talk. So this session, the last speaker is Dr. Panush Samdash, yeah, Samdash. Currently serves as assistant professor at the Amrita University, Bangalore campus. His research concerns the Buddhist philosophy and the lecture on Tantra tradition of India and Tibet. He has authored 2 books and published several research papers and reviews. He has also designed and taught courses for Buddhist studies at Namgyal Institute of Tibetology, Gangtok, and Indira Gandhi National Center for Arts and Arts in Delhi. So, Dr. Smati, welcome.
Thank you, Most Venerable Ken Rinpoche Tashi Sheringla. I'm grateful to Tibet House and IIWC as well as Choskar Ring for giving me this opportunity to explore something, which is not main part of my mainstream work. So there are going to be certain outer territorial area which I'm going to step in. Anyway, actually it's quite fortunate that we are doing something in Bangalore. Just 6 months back I had the privilege to give a talk here in IIWC on 17 Nalanda masters. And what you are seeing here, they are 17 Nalanda master. Interestingly, my lecture was how the South India contributed to Nalanda tradition. And here out of 17 Nalanda master, we study, I'm part of master's course in Tibet House. So this 17 Nalanda master, out of these 17, 12 of them are from southern part of India. So a great contribution has been there from South India, but we are not aware of it. So we'll begin with Aryadeva. Aryadeva was disciple of Nagarjuna. He came all the way from Sri Lanka to study Nagarjuna. At that time, Nagarjuna was staying at Nagarjuna Konda, which is in Andhra Pradesh. This is something very unique thing is there in Buddhist soteriology, which means, aspiration for emancipation from suffering. In Buddhist soteriology, utmost importance has been given for true reasoning and inquiry for the reality. So here I'll recite certain Sanskrit verse, because originally all Buddhist texts were written in Sanskrit. So here Aryadeva says, Asmin alpa punyasya sandehopi na jayate, bhava sandeh matrena jayate jarjari krita. The English translation goes like that. He's saying, Alpa Punya, those who have less merit, those who are not so intelligent, that's not a direct meaning here, but Alpa Punya, less merit, they will never question this reality, this existence of reality. But he says, if you start inquiring the real nature of reality, it will shatter samsaric existence into pieces. So very importance has been given for inquiring about the reality in the whole Buddhist philosophy, which ultimately it is for the soteriological purpose. So again, another South Indian master from Tirumala, bordering Karnataka, Tirumala, Tirupati, Dharmakirti. In his Nyaya Bindu, he says, Samyak Jnana Purvika Sarva Purusartha Siddhiti. Comprehending the correct form of reality is the final accomplishment of all human pursuit. Purusartha Siddhi, all the human pursuits will be achieved if somebody is able to comprehend the reality. Albert Einstein, he says in 1934, like long back, we should remember this dating also, because in the coming slide something different is coming. Behind the tireless efforts of investigator, there lurks a stronger, more mysterious drive. It is existence and reality that one wishes to comprehend. A very similar approach. But let us see the problems of physics now. Physics may seem focused on the objective, determination of fact, yet the field has just as many, perhaps more, struggle with the notion of truth as any other discipline. Quantum mechanics, for instance, suggests that particles have no definite reality. By most interpretation, their properties are undecided until measured. So it's about just measurement and observation. Lately, like contemporary, that means scientists are interested how the uncertainties of physics affect of the largest uncertainties of science. The question of how consciousness operates. Just we had an interesting paper from Dr. Ravi. So here, this is a quantum decoherence. Or decoherence here, it's about, when a wave function collapses, where the particle is going to exist. So probability is of the existence of the particle. So here it's depicting the transition state from quantum state to classical state, and we don't have a exact reason why a particular locality or a space is found when the transition is happening from quantum state to classical state. So we don't know, as Professor Usadevi explained, the Schrodinger's cat. We don't know how, whether the cat is alive or dead. And in fact, Schrodinger was so much shocked from his discoveries that he gave up his, career in quantum physics. He got interested into biology because he was so shocked. So at contemporary, the scientists are saying, Stephen Hawking, for example, he's saying, I don't demand that a theory corresponds to reality because I don't know what it is. So nowadays, physicists are not actually inquiring for the, what is reality, because it's, giving a shock. Max Planck says, if understanding of quantum physics does not give you profound shock, that means you haven't understood it. So we'll go now how Buddhist philosophy sees the reality. So the very interesting this technical term, very heavily loaded term, Pratyatya Samutpad, theory of interdependent origination. One of the fundamental tenets of be it Theravada, Buddhism, Hinayana, Mahayana, whatever. It's one of the fundamental tenets, which says it's made of separate words. Pratyatya Samutpad. Prati is term for in front, something which is in front of you. Pratyaksh, in front of you. Tya is a term for motion. Something is moving, like transition is happening. Sam means together. And utpad, which means it has another two terms within it. Ut and pat, arising and disintegrating. So that is utpad. So it's something which is in front of you, in front of object and subject, the interaction, which is into motion, they are together and something is being produced. So that's the etymological meaning of this technical term, Pratyatya Samutpad, which we generally So it's interdependent production set into constant motion. Interdependent means a subject is there, object is there, they're interacting constantly with each other. So we roughly translate it as a dependent origination. So this is the idea. This is I've taken from Prasannapad, which was translated by, authored by, in 9th century by the great Nalanda scholar Chandrakirti. He was from Kanchi, Tamil Nadu. So we have Arya Nagarjuna. In Mahayana philosophy, Nagarjuna discovered all the Pragya Paramita Sutra. We can see a Naga handing over Pragya Paramita Sutra to Arya Nagarjuna. So he says that he equates Pratyatya Samutpad with Shunyata. Shunyata is another heavy technical term. He says that Ya Pratyatya Samutpada Shunyatam Tam Prakshakshamahe. Sa pragyapti rupadaya pratipatsaiva madhyama. He says that whatever is dependently produced, interdependently produced, that is what I'm calling empty. It's not, emptiness does not mean voidness. It's with interdependent production. So it's very clear. He says Pratyatya Samutpad and Shunyata, they are equal. Pratyatya Samutpad posits the conventional reality. Shunyata posits ultimate reality. So he says that it's all being conceptually designated. Pragyapti, very important term. Pragyapti means japit hona. That means, you cognize. And pra is pradhan, something prime cognizance. So all manifestations happening because of this, pragyapti. Conceptual elaboration. How the reality is coming into place. So we go to Acharya Chandrakirti's Madhyamaka Avatar. He says that all phenomenal worlds are being created by the karmic propensity of us, of all sentient beings. He says, Satyam loka athbhajanam lokam. Chittam eva rachayate ati chitram. Karmajam hi, very important term, karmajam hi jagatam uktam ashesham. Karma produces this phenomenal world without any reminder. This is what has been said by the Buddha. And once the karmic wind is vanquished, there is neither karma nor the world. So what he is trying to say that subject, object, they are constantly, producing this reality. This also often comes, including in Abhisamaya Alankar and also in Madhyamaka Avatar, that it's a mind-made reality, Manomaya Jagat, mind-made formations. For example, for the butterflies see more color than us. Now scientists don't know what more colors they are seeing, but they have a capacity to know that at least they are seeing something more than us. So it's a species specific word. Species, right now I was reading one of the prominent neuroscientists who says that actually through the process of evolution, human beings are seeing this reality in certain form. We are not seeing the actual what it is existing actually. Because of our mind is making us to see this reality. That is why we are seeing it like that. So long back, Madhyamaka Avatar as well as Abhisamaya Alankar in 3rd century BC, Acharya Asang from Pakistan, present day Pakistan, from Peshawar, he says that actually the water of Ganga water does not have its own existence. It depending upon the various sentient beings' karmic propensity. For example, for ghost beings, it appears as a dry sand. For human beings, it's a water. For devas and devis, it's a nectar. We don't know what we don't have to believe in ghost or what he's trying to say, that it's based on sentient beings' karmic propensity, the actual reality is appearing. So that's the idea. Acharya Chandrakirti further says, Graham vina grahak taviyuktam. Without the apprehended make no sense. They both are empty and not independent. If this is devoid of both, by what it exists, without apprehending it, you cannot say that it really exists. So this also traces it back to the sutra literature. Here Upali Pariprachya Sutra, where Buddha says that the various delightful flower blossom and sparkling golden abodes stand alluringly. They have no creator. They are posited by the power of thoughts. Through the power of conceptualization, the word is imputed. So tepi cha sthapit kalpa vashena. So in the dream state, we see the reality and we start having, to believe, a strong belief that our dream state is the real, nature. Similarly, what here Buddha is saying, that we live in a dream sort of reality. That's all. It also comes in the whole tantric literature. For example, here we have a four-faced Heruka, Sri Heruka. So Sri Karam, this is from Hevajra Tantra. Sri Karam Advaya Jnanam, He Karam Hetvadi Shunyata, Ru Karam Apgata Vyuham, Kakaram Nakvachit Sthitam. Which means here that the mind here, actually all these deities have a very important symbolic meaning in them. So here even the name has symbolic meaning. He is which says He symbolizes the mind which is cause behind all phenomenal manifestation. Ru is the web of conceptualization which we start grasping as a true self of person. Ka is the ultimate reality, which is absence of dissonance, absence of dissonance between subjective reality and objective reality. And Sri is the non-dual gnosis, the Advai Jnanam. So this is the symbolism of Sri Heruka. Now, what does this all, idea leads to. We have this I have taken from Professor Christopher Fuchs. I had a very good fortune he is the founder of this idea of cubism. I had a good fortune to interact with him for 2-3 days when I was in Gangtok. So this slide I have taken from him. He is one of the top physicist, contemporary physicist. He says that the sophisticated quantum information experiment, actually the observer or the experimenter, you can see the merging of the subject and object. So that sort of thing is happening in actuality. So this leads to a very, very profound and drastic change in the approach for soteriology. R.A. Nagarjuna is in Mool Madhyamik Karika. He says that what is category of nirvana is the category of samsara, and there is not even the finest gap between the two. So here a very important practice. Some of you might be knowing this already. Those who are going to the Rebat House or the Center for Dharma in Bangalore. Swatma Parivartan, transforming self to other. This is from Bodhicharya Avatar chapter 9, where Acharya Bodhisattva Shanti Dev says, yes, that one, it's a practice called Tonglen, where the self, as we saw that object and subject, they both are affecting each other. So transforming of self to other, Swatma Parivartan, which leads to the selflessness of feeling for the other. So if I'm doing harm to somebody, finally it is he extension of myself. If I'm harming the nature or even the inert reality, it's extension of my own being. So finally it is as you can say, transforming self to the other. So ultimately it's me who is being harmed. So that's the idea. So this led to quite a drastic approach, where Bodhicharya in Bodhicharya Avatar Shanti Devi is saying that Sattva Kshetram Jinam Kshetram Ityena Munina Uditam. This Sattva, the sentient being realm, is the realm of Jina Kshetra, is the Buddha realm. And Etena Aradhya Bhava Satpa Paramo Yatogata. By serving the sentient being realm, one can achieve, transcend the, ocean of samsara. So this led that the ultimate service to the, Buddha or for emancipation is to serve the sentient being. So this was the idea, and finally, which it led to, this different concept of soteriology. So my time is up, so I'll conclude with this profound prayer, which is also a prayer of daily prayer of His Holiness Dalai Lama, where he says that Akasasya sthiti yavatcha jagatah sthiti tavan mama sthitir bhuyat jagat dukkhani nignata. As long as space remain, as long as sentient being remain, until then may I too remain to dispel the miseries of the world. Thank you.
Thank you, Dr. Pranush. So, started with amazing this painting of great 17 Indian masters. Traditionally, we count at 7. His Holiness the Dalai Lama, some years ago, he thought that's not that 7 great Indian master. When when we do the prayer, it's not really not included many great Indian masters that very, very important for the Buddhist, the Indian Buddhist, particularly Nalanda Buddhist traditions to understand. So His Holiness Dalai Lama, some maybe 10 or 12, 15 years ago, he put together this 17 great Indian pandits. So Dr. Prashno start from that, and then seems he's very keen to southern India. Out of 17 pandits, 12 will come from South India. And quite often His Holiness Dalai Lama, the thesis to the people coming from the East India, saying many of those ancient Indian great masters are mainly came from South India. There must be something in there. So anyway, I think the main conclusion here is really one of the most important among the historical Buddhist teachings, one of the most important topic that is the Patita Samuppada, and here quite often translated saying the dependent origination or dependent arising or interconnectedness. All things and events are interconnected. Nothing is standing by on itself. Everything is connected and interdependent, and that topic is really crucial for the people who really want to know the teachings of the Buddha. That topic, interconnectedness, that theory explains many of the profound teachings of the Buddha, starting from his Four Noble Truths, and can continue to Dr. Pashun touch on the Nagarjuna's teaching on the Mula Madhyamika Avatara, and so on and so forth. And I will not go any detail on those. And Doctor concluded from this another great Indian master, Shantideva, which he wrote two important texts, and he concluded this nice verse: as long as space endures, as long as sentient beings remain, may I remain and dispel the miseries of the world, which is extremely moving statement, and a very important verse to be remember every now and then. As Doctor mentioned, the meaning of our existence is really very much serving for the others. And so I will conclude from there. Thank you very much for your moving talk. Now I've got the short notes, so we will take only 2 questions because we are already the 20 minutes late from our lunch. So we'll take 2 questions. So first I will take from the madam, then the second there. So I will take those 2 questions. You start.
For your nice lecture, but I have one small query. In one of your slides where you explained the notion of Pratitya Samutpada, there I found something different from what is given in the Prasannapada commentary. There you interpreted, if you can show the slide, you can find that Pratitya Samutpada you written Prati with E as but it should be Prati plus Itya. Prati plus Itya, then Samo plus Utpada. And here you are interpreting it in the sense that subject is dependent on the object, but actually here you find Prati is an obboy, so it is always with small e and not dirgha e. This is what. And itya means itya comes from the verb e with the suffix lop, so it means going. That is, it is actually samutpada, that is origination. From this the question comes. So that samutpada originates by depending on the causes and conditions. This is the sense. And just one. No, my point is that if you take it as object as dependent on the subject, then will Nagarjuna be regarded as a subjective idealist like Dingnago, and because he ultimately he didn't admit the existence of the sense.
Request all the question people asking to please point to your question. Thank you very much.
So one thing we should know that the Buddhist sometimes many texts they interpret they do not follow the strict Parthian way. So here I was not much. I'm not a Sanskritist as such. So there might be a mistake in ti, harasva or dirgha. But this interpretation is there in Prasannapada. In the first chapter, it is there where he is refuting the interpretation of Bhavya Vivek. Actually, there are several Madhyamik school. Within that, there are several divisions. This interpretation is given by Prasangik Madhyamik school. There is another Swatantrik Madhyamik school founded by Bhavya Viveka who talks about this Utpat, production and so there are several different interpretation of the same Pratyatya Samutpad theory. So it depends upon which school somebody is following. So as I said, like I'm making it clear now that I'm giving the interpretation of Pratyatya school. Thank you.
It's very clear now. Now there's a written question. I will take this one. Then the one last question. There's one gentleman.
Okay. The question here is, does the mechanism of transition of quantum realm into objective realm remain unexplained? No, I will say that quantum theory explains how one goes from quantum to classical or objective realism through what is called as system-environment interaction. And I also said to observe what is the quantum realm in this kind of a system, we have to slice time into very close observation is needed. So otherwise we have all the thing. And I also would say that quantum theory has many counterintuitive features which we are unable to see in our day-to-day or whatever is called as objective realism. But to see it, we have to have different eye. That's all I would say.
Okay, last question. Can you point to the person whom you are asking?
The
Just
question is-
very sharp, not
The
in
que-
the background.
Thanks.
Thank you.
The question is to Dr. Ravi Prakash. Yeah. Doctor, how do you teach this? How do you teach this research to monastery students who have just studied the Shastra?
A very difficult question, actually. I was not expecting this probability. No, teach what? My research. See, my research is associated with consciousness, basically. And I want to go deeper into the understanding of the development of consciousness, how the brain, the embodiment of consciousness in the brain, how the brain functions. Basically, it will be, if really there is a consciousness theory, it will be an integrative theory. It will involve all the branches. It cannot be just one theory. So teaching, it's just like any other teaching. You have to understand the basic building blocks, and from there the different permutation and combinations, then you have to move ahead. You have to understand little bit of neurology, little bit of quantum physics, little bit of computation. Okay, because we go to quantum computation from the classical computation. We cannot just jump to quantum probability understanding without understanding what is a classical probability. Maybe it is explained by classical probability. So it's the same thing, like you learn swimming, you learn to play guitar. With simple building blocks, you have to move ahead. Cognitively, I'm saying, if I don't know if there is an internal mechanism by knowing by this meditation and all these people they do, there are many different techniques of meditation which are very difficult to explain how a person achieves knowledge by that. I have seen in my own experiments. Okay, I have done experiments on inner light perception, near-death experiences. The knowledge that the person gets in that phase, I don't know how people get. Okay, but I'm talking about the scientific way of learning. Just like any other scientific way, you have to understand the building blocks of neurology, quantum physics, simple computing, then you move towards a permutation and combination to whichever area you want. There are so many interesting areas that one life is not sufficient. Not for me, not for anyone.
Oh, yeah. So we are going to conclude this session, and I would like to thank all three great speakers. Your amazing, inspiring speech, which is very, very helpful. Thank you. Thank you.
Thank you very much, Rinpoche. As a part of organization, so may I request Chairman Geshe-la to present the scenario to Usha Devi ji. Come. Thank you very much. May I request Dr. Ravi Prakash ji. And from Shri Samdarte ji. Thank you again, one and all. So I have several questions to ask to speakers. I'll take it off session. And anybody have any questions to ask, please go ahead. Speakers will be available post lunch. Also, you can take it off session. And we are more stomach hunger than brain hunger. So request all participants will shortcut the lunch break from 45 minutes to 30 minutes so that we'll have more session, interactive session, question answer session. Thank you very much. Thank you, Anandal. We have a lunch break now.